And welcome everyone. So this video is number 3, or the lecture over chapter 3 of the OpenStax Principles of Microeconomics text. It's on demand and supply. If you haven't already, you can go to OpenStax, openstax.org, go to subjects, business, economics, and then microeconomics, third edition. You can get a copy of the PDF version of the book. You can order a hard copy, physical copy version of the book as well, or click through the view online. That's useful if you have a tablet or something. Problem is that's not going to have page numbers, so I would download the PDF and then you'll have that available. Or also, though this isn't the content for this particular lecture, I've got my microeconomic principles Substack, microeconomicprinciples.substack.com, which has a chapter on supply and demand and lots of practice exercises and past exams. Excuse me. Okay, so we'll go ahead and get started. The outline for this lecture is demand, supply, and equilibrium in markets for goods and services, shifts in demand and supply, this is what we call comparative statics, changes in equilibrium, price, and quantity, there's a 4-step process that they're going to recommend, and then we'll think about price controls, price ceilings or price floors, and then we'll think about the relationship between demand, supply, and efficiency, that's consumer and producer surplus. Okay. Why does it cost more? Organic vegetables and fruits are often grown and sold within a specific geographic region. It should, in theory, cost less than conventional produce because the transportation costs are less. That's not, however, the case. This is caused by demand and supply. Well, okay. I mean, maybe because of lower transaction costs or transportation costs, you might think it would cost less. Probably there's a couple different things going on here. I think what this is hinting at, of course, is that there's an increase in demand. There's greater demand, higher willingness to pay for organic vegetables and fruits because consumers perceive that this is something that's probably going to have a higher cost structure and it's going to necessitate higher price, and or people might just have that perception going in. But probably conventional produce is going to generate output at a lot larger scale, maybe a lower average cost. So the supply curve is completely different. So actually probably the costs are higher for actually producing the organic fruits and vegetables. I might be wrong about that, even though the transaction cost to get them to a particular market might be lower. Anyway, demand is our definition. The amount of some good or service consumers are willing and able to purchase at each price. By demand, you want to think about the entire relationship between all prices and all quantities. We can represent demand with an equation, we can represent demand with a table, we can represent demand with a graph. And when we talk about demand, that definition is invoking the entire relationship, the entire set of plans that consumers have, such that if we give them a price, with their demand relationship, we'll know the quantity they want to buy. Price, that's what a buyer pays for a unit of the specific good or service. Okay, so the market price is what the buyer is going to be paying, and then we'll find the associated quantity demanded in the demand relationship. So quantity demanded is the total number of units of a good or service consumers are willing to purchase at a given price. Well, right, in the context of the demand curve, given a price, we can find the associated quantity demanded. Law of demand says keeping all other variables that affect demand constant. This is like our ceteris paribus assumption. Other things held constant, other things equal. Then if price is all that changes, we expect quantity demanded is going to go down, or if price goes down, quantity demanded goes up. The idea is at higher prices, there's a lower quantity demanded. At lower prices, there's a higher quantity demanded, and that's summarizing the law of demand. Okay, so in particular, I want to emphasize these two key definitions. By demand, we're referring to the entire relationship. If we're talking about the amount people want to buy at a given price, that's quantity demanded. This is really important for the distinction between when we're asking the question of what changes and thinking about changes in terms of shifts versus movements along the line. Okay, so I mentioned demand can be represented with an equation, with a table, with a graph. The table version is the demand schedule. So this would be a table showing the range of prices for a given good or service and the quantity demanded at each price. The demand curve is the graphic representation of the relationship between price and quantity demanded of a certain good or service, with quantity on the horizontal and price on the vertical. Right. And lots of times we'll draw a linear demand curve. We'll still refer to it as a demand curve, even though oftentimes we're going to represent it with just a constant slope, downward sloping straight line. Now that's an assumption, and that's a simplification, although it turns out usually, and you see this here, over the relevant range of demand, we expect the demand relationship is going to be approximately linear anyway. So it's not too big of an oversimplification. Doesn't get us in too much trouble. Although you should recognize that the real demand relationship probably isn't a perfect straight line like we'll draw in class often. Okay, so here's graphing the demand. This is going to be price per gallon of gasoline and then gallons and millions of gallons, right? And so the demand curve is capturing all the relationships between prices and quantity demanded, right? At a given price, we have a single quantity demanded. Given price, we have a quantity demanded. I guess I moved to the wrong tick mark on the graph, but whatever, you get the idea. The points of the demand schedule are graphed here, and then the line connecting them is the demand curve. Yes. The downward slope of the demand curve again illustrates the law of demand, the inverse relationship between prices and quantity demanded, right? At higher prices, there's a smaller quantity demanded. At lower prices, there's a higher quantity demanded. Okay. Now we can introduce supply. Supply is going to be the entire relationship between prices and quantity supplied. Similarly, we can represent supply with a supply curve. Typically also we draw this with like a constant slope upward sloping straight line. Or we can also represent the supply curve, supply relationship in table format, and that'll be the supply schedule. Quantity supplied is the total amount of goods or service, total number of units of a good or service producers are willing to sell at a given price. I'm tripping over like the way that I usually would teach it versus like the definition that's here. So, all right. The idea is at a given price, there's a certain number that sellers are willing to bring to the market. That's their quantity supplied at that specific price. The law of supply says other things equal. When we hold constant all the other things that might affect supply, as price goes higher, quantity supplied goes higher. As price goes lower, the quantity supplied goes lower. Now, we're more confident in the law of demand than in the law of supply, right? The law of demand, we have pretty good empirical evidence for this. In a lot of cases, basically everything we cover in class, the law of demand holds. The law of supply suggests the supply curve must always be perfectly upward sloping, although we can think of different things happening with supply. And so that's kind of important to keep in mind that we might get a horizontal supply curve, such as the long run supply. We could also get a vertical supply curve if the total amount is fixed, so that it doesn't matter how high the price goes. You can't bring any more to the market. That'd be a perfectly inelastic supply. But anyway, I just wanted to point that out. Yes, the law of supply is as price goes up, quantity of supplies goes up. There's a positive relationship or a direct relationship between price and quantity supplied. Okay, supply schedule. This is a table that shows the quantity supplied at a range of different prices. Yep, so it's just like the demand schedule, only now we've got the price and quantity supplied. Supply curve is the graphic illustration of the relationship between price shown on the vertical, quantity shown on the horizontal. That's right. And again, as I said before, now for the second time, the supply curve is going to be our graphical depiction of the supply relationship, and we'll call it a supply curve even if it doesn't literally curve. Even if it's just like an upward sloping straight line or even a vertical line, we'll still call it the supply curve. Here's the supply curve, which is the graphical representation of the supply relationship. So at a given price, there's a quantity supplied. At another price, here's another quantity supplied. Right, and the idea is you can think of supply as the entire set of plans, in this case about how many millions of gallons of gas the gasoline company is willing to supply at a given price. At higher prices, they're willing to bring a larger quantity to the market. And the idea is it probably costs them a lot more to bring larger and larger quantities. They have to have more. I mean, think about the supply chain. They have maybe more trucks or whatever shipping these out to their affiliated gas stations or something along those lines. So there's going to be higher cost to bring a larger volume, but if the price is higher, it's worth doing that. So they'll gladly incur the higher costs if the price per gallon is a lot higher. The supply curve is created by graphing the points from a supply schedule, then connecting them. The upward slope of the supply curve illustrates the law of supply, that a higher price leads to a higher quantity supplied, and vice versa, meaning a lower price, we have a lower quantity supplied. And actually, the thing that I mentioned is really kind of important. You can think of the vertical height of the supply curve as representing the marginal cost to sellers, right? So if I just measure from the horizontal axis up, this is telling me that actually on this supply relationship, the lowest per unit cost is $1 per gallon. And this tells us that if the price of gasoline falls below $1 per gallon, the sellers can't cover their costs. If the price rises above $1 per gallon, now they'll actually produce 500 million gallons. Actually, let me go back for a second. Sorry. If I go back to demand, we can think of the vertical height of the demand curve as capturing the maximal or capturing the willingness to pay of consumers, right? So for this given quantity, here's the willingness to pay of consumers. Anybody who's willing to pay $1 per gallon is going to buy when gas is that price. And then there's so many people or enough people to sell 800 gallons worth. At least in this demand relationship, the most consumers are willing to pay is $2.20 per gallon, right? And there's only enough consumers to sell 400 gallons worth at that price. Okay, so equilibrium. Equilibrium is where demand and supply come together. So this is the point where quantity demanded equals quantity supplied, not where demand equals supply. Yes, it's where demand crosses supply. It's where the demand curve and the supply curve have a common point. But it's not where demand equals supply. It's where quantity demanded equals quantity supplied, and in particular at the specific price that makes that true. So that level of precision is actually really important to save yourself points on exams, right? Okay, equilibrium is the combination of price and quantity where there's no economic pressure from surpluses or shortages that would cause price or quantity to change, right? So the idea is if the price is too high, buyers lose interest, they leave the market, so the quantity demanded falls, and then eventually sellers have to lower the price and we restore equilibrium. Or if the quantity supplied is too big, eventually the price has fallen, so consumers are willing to buy a larger quantity demanded, have a larger quantity demanded at that lower price, and then eventually like the item goes on clearance or goes on sales, and then eventually the market clears, meaning quantity demanded equals quantity supplied. The equilibrium price is specifically the price where quantity demanded equals quantity supplied, right? I said the equilibrium is where quantity demanded equals quantity supplied, and the price that makes that true, that's this right here. The equilibrium quantity is the specific quantity that's the same, quantity demanded and quantity supplied. That's easy to see if you have a demand schedule, if you have a table, well, a demand schedule and a supply schedule if you have a table. Surplus or excess supply is if at the given price, the quantity supplied is bigger than the quantity demanded. Shortage or excess demand is if at a given price, the quantity demanded is bigger than the quantity supplied. You can measure the size of the shortage or the size of the surplus by subtracting the smaller one from the bigger one of quantity demanded and quantity supplied. Okay, so we can show that here. At all above equilibrium prices, meaning here's the equilibrium, it's $1.40. At all above equilibrium prices, including $1.80, that's higher than the equilibrium price, quantity supplied is going to be bigger than quantity demanded. So by definition, you'll have a surplus. We can see that because just pick a point, make a horizontal line corresponding to that price. You'll bump into the demand curve first, which means a smaller quantity demanded, and then you'll bump into the supply curve. Larger quantity supplied, that's going to be a surplus. At all below equilibrium prices, namely like $1 or $1.20, if you do that same exercise, you'll run over on a horizontal line, you'll bump into the supply curve first, so you'll get a smaller quantity supplied and a larger quantity demanded. Notice at the equilibrium of $1.40, if I do that exercise, I bump into demand and supply at the same time. That's where quantity demanded equals quantity supplied. Right, so at any price above the equilibrium, QS is bigger than QD, so there's excess supply. And at all points below the equilibrium, QD is bigger than QS, so there's excess demand. Oh, in this case, you'd say the surplus at a price of $1.80, surplus at the price of $1.80. Oh, they didn't have the tick marks on here. This is too bad. It looks like maybe 680 minus 500, so the surplus would be like 180. Okay. This one maybe is $1 at the price of $1. No, they still can't do that. At a price of $1.20, this looks like maybe 540, and the quantity demanded is 700. So I don't know. You'd say maybe there's a shortage of 160. If this is 540, 540 plus 160 gets us to 700. Anyway, you can calculate the shortage or surplus by subtracting whatever is the smaller of quantity demanded and quantity supplied from whichever is the larger. And that'll be the size of the shortage or surplus respectively. You'll know it's a shortage if quantity demanded is bigger than quantity supplied. You'll know it's a surplus if quantity supplied is bigger than quantity demanded. I mentioned ceteris paribus. That is our other things being equal assumption. So any demand or supply curve is based on the ceteris paribus assumption that everything else is held constant. That means we're focusing only on changes in price, right? Not in anything else. We have a whole list of demand shifters and supply shifters. We'll talk about that shortly. And we're basically ignoring the effects of all those. All right, so on our demand curve can be used to identify how much consumers would buy at a given price, right? So here's P naught and here's Q naught. At a given price, here's the quantity demanded. I talked about that a little bit already. If income increases, we get a shift in the demand curve. Consumers are going to purchase larger quantities, pushing demand to the right. So we actually would have figure B, thus causing demand to shift to the right. Right, so the way this would look in a demand schedule is you'd have your original demand for figure A, demand A, and then you'd have your new demand, demand B. Your demand A would have smaller quantity demanded everywhere. And then your demand B would have larger quantity demanded everywhere, indicating that at the higher income, if your income increases, you'll be able to buy a larger quantity at all possible prices. That's why it's a shift. Right, so income increases, consumers will buy larger quantities, pushing demand to the right. Oh, only if we have a normal good. A normal good is one for which as income increases, consumers buy more. If you have an inferior good, as income increases, consumers buy less. If you have a normal good, as consumer falls, consumers buy less. If you have an inferior good, as income falls, consumers buy more. So that's actually really important. This says if income increases, this is true if we're assuming we have a normal good. I hope they make that distinction later on in here. All right, so increased demand means at every given price, the quantity demanded is going to be higher, so the demand curve shifts from the right from D naught to D1. This is basically what I was saying with the table. If you had a demand schedule, I didn't show you a table, but I said the demand for A and demand for B. Demand B was our shift. Everywhere there's going to be a higher quantity demanded. That's basically this. So here's D naught, here's D1. At every place on D1, you're going to have a larger quantity demanded at every given price. Or if you have a smaller quantity demanded at every given price, that's a decrease in demand, a leftward shift. That's this right here. It's important to talk about demand shifts and actually supply shifts as leftward shifts and rightward shifts. You can get yourself in big trouble if you try to talk about them as being upward shifts or downward shifts, right? I mean, mathematically that's not wrong, but the intuition's a little bit strained, so it's a little bit difficult. You'll set yourself up for more success if you always think of increase in demand as a rightward shift and decrease in demand as a leftward shift, and same thing for supply. Right, shift in demand happens when a change in some economic factor other than price causes a different demand or different quantity to be demanded at every price. So factors that affect demand are income, put an asterisk next to that, because it matters, do you have a normal or inferior good? Changes in tastes or preferences, changes in the composition of the population, like number of buyers, change in the price of a substitute or complement, and change in expectations about the future. Now, importantly, we'll say if price changes, only quantity demanded can change, or quantity supplied if we're talking about the supply side. If something other than price changes, you get a shift. That's what this is doing. Here's 5 of those possible shifters. These are the most common. But basically, the good guideline you want to follow when you're trying to figure out is it a shift or a movement along the curve, or is it a shift or is it a change in quantity demanded, is ask yourself, did price of the good change or did something other than price change? Okay, so here you might look at this and you might say, oh, well, wait a second, this is a price. Yes, but that's not the price of the good under consideration. This is the price of the related good, of the substitute or complement. So in those markets, you'll get a change in quantity demanded. In the market we care about, you'll get a shift. Changes in expectations about the future are often expected future prices, and sometimes people will say, oh, but wait a second, there's a change in price there. No, what's changed was your expectation, your belief about the price in the future. And so it's a shifter. Okay. There's more on that in my Substack. I think I do a better job than probably this text does on that. But anyway. All right, so how factors affect demand? Tastes tend to shift to greater popularity. Population likely to buy rises. Income rises for a normal good. Good, they make that distinction. For an inferior good, you get a leftward shift. Price of a substitute rises, you'll get an increase of the good under consideration. Or if the price of a complement falls. Substitutes are goods that are used in place of each other, like Coke or Pepsi. Complements are goods that are used together, like ice cream and ice cream cones. Right? So if the price of Pepsi rises, you'll get a smaller quantity demanded of Pepsi, but you'll get an increase in demand for Coke. If the price of ice cream falls, you'll buy more ice cream. You'll also buy more ice cream cones. That's what this is saying. All right. Right. A list of factors. Panel A is a list of factors that cause an increase in demand. The same factors, if their direction is reversed, can cause a decrease in demand. Right. All right. So normal good is a product where demand rises, income rises, and vice versa. An inferior good is one where demand falls when income rises. I don't know what this rises means. Oh, rises if okay, how about I'll just like ignore the slide for a second. A normal good is one where as income rises, you buy more. As income falls, you buy less. An inferior good is one where as income rises, you buy less. As income falls, you buy more. I can make a change to the slide, but if you remember from the first lecture, it says all changes must be indicated or identified to keep within the OpenStax copyright thing or whatever. So I don't want to make changes because then I have to, every time I make a change, I have to indicate that I made the change. So instead what I'll just do is say it verbally and then I don't have to do that. All right, substitute. A good or service that can be used in place of another good or service. That was like Coke or Pepsi, like I said. And then complements. Goods or services that are often used together, so the consumption of one good enhances the consumption of another. I gave the example of ice cream and ice cream cones. You could think of like pumpkin and pumpkin pie, or pumpkin and pie crust or something, or whatever. All right, so here's supply. Here's our supply curve. The supply curve can show the minimum price a firm will accept to produce a given quantity of output. Well, this is like what I was saying. The vertical height of the supply curve corresponds to the marginal cost of that unit. Oftentimes, I like writing marginal cost in parentheses below the supply curve just so we make that clear. But yes, at a given price, here's going to be the quantity supplied. The cost of production and the desired profit equal to a price a firm will sell for a product. Right. So here's the price. The price is going to be the desired profit plus the cost of production. Wow, that's a wild way to describe this. All right, so the profit is going to be like our producer surplus. That's going to be the difference between the price and the marginal cost. So let's see. Revenue would be this whole box right here. Revenue is price times quantity. So that would be this box. Cost is going to be just the area under the supply curve. That's just this lower triangle. And then profit is actually going to be this upper triangle because you'll take this big square, that's revenue, you'll subtract off costs of production, which are right here, and you'll be left with this kind of upper triangle that's not really labeled there. And that'd be profits. Okay, so hopefully that clarification helps because I don't know that I'd be able to make sense of this slide. Okay, let's see. So because the cost of production and the desired profit equal the price a firm will set the product. If the cost of production rises, the price for the product will also need to rise. Yeah, right. So at higher production costs, you need a higher price to justify the production of that good, right? So let's see. The desired profit, they want this is their desired profit, and so this is going to be the cost to produce that level. Well, okay, fine, but I don't know that desired profit really makes sense in the context of this model we're developing, because usually when we think about the supply and demand model, we're assuming we've got a competitive market. And so we're assuming price equals marginal cost at the equilibrium. If this was the price, actually, we're not going to be selling this quantity. We'll be selling a quantity all the way over here, but there'll be actually zero economic profit. So I'm not really 100% sure. I'd actually probably have to look at the text to see exactly what they're trying to do here with this desired profit thing. I don't know. I'll give them the benefit of the doubt. Maybe there's something interesting they're talking about here. When the cost of production increases, the supply curve shifts up to a new price level. Wow. All right. So if our production costs are higher, then we'll be able to produce less at every possible price, right? So you'll produce less at every possible price if the production costs are higher. That's a leftward shift of supply. So we're going to get a leftward shift of supply. Here they are talking about the supply curve shifting up, which I think is that's really messy. You should talk about supply shifting left, as I said. Demand increases, supply increases, both as right shifts. Demand decreases, supply decreases, both as left shifts. This business about upward shifts or downward shift, I know why they do it. It's because if you look at the vertical intercept, that's going to be the lowest marginal cost, and now we get a higher lowest marginal cost that must be met to be able to operate in that market. So it looks like an upward shift, but I'd still call it a leftward shift. Wow. Okay. Decreased supply means that at every given price, the quantity supplied is lower, so the supply curve shifts to the left. Yep. So at every price, let's see. At every price, the quantity supplied is smaller. Yep. And so we'll get a leftward shift. Or increased supply means that at every given price, the quantity supplied is higher, so the supply curve shifts to the right. This is way better. I don't know why they're bothering with this shift up thing here, but this is better. Here's a rightward shift to supply and a leftward shift to supply. That's the correct way to think about it, or maybe the most helpful way to think about it. Okay, shifts in supply. When a change in some economic factor other than price causes a different quantity supplied at every price. Right, so the idea is at every price you have a new quantity supplied. In the case of a decrease in supply, you have a smaller quantity supplied at every single price. In the case of an increase in supply, you have a higher quantity supplied at every single price. And it's that you have a higher quantity supplied or a different quantity supplied at every price. That's what makes it a shift instead of a movement along the curve. Let's see, inputs are factors of production. The combination of labor, materials, and machinery could be used to produce goods or services. That's right. So factors that affect supply, natural conditions, input prices, technology, government policies. Yeah, I mean, usually what we think of are supply shifters, right? So I don't want to change the slide because like I said, I don't know exactly how they want me to indicate that, but let me just say verbally what we usually think of as our supply shifters. This is also in my Substack. So it would be a change in important input prices, right? So whatever you need to produce, if like the price of labor rises, that's going to cause a decrease in supply. It's going to be a change in the number of firms, right? So if there's more firms in the market, that's an increase in supply. Fewer firms in the market, that's a decrease in supply. Change in the price of related goods or services the firm could make. So if there's something else that they could better be using their resources towards, they'll shift to that thing instead, switch to that thing instead. So there'll be a decrease in supply. It's like Apple, right? It's Apple computers. They made the iPad, then the iPhone, then the iPod. No, iPod, then the iPhone, then the iPad. They basically no longer make the iPod. And the reason why is people aren't willing to pay very much for it. So as the price of the iPod falls, Apple realizes they're literally wasting their time making iPods. Instead, they allocate all their resources to making iPads and iPhones. So we get an increase in supply of both of those things, a decrease in quantity supplied of iPods. Let's see, other things that affect supply, also expectations, so expected future prices. If you're sitting on some type of non-perishable resource and you think the price is going to be higher in the future, you won't sell it today. So it'll be a decrease in supply today and then an increase in quantity supplied in the future at the higher price. Also, just general like natural conditions, like if there's a drought or something, that would affect agricultural production. There'd be a leftward shift to supply. We could think broadly about production technology as another supply shifter. Yeah, government policies, technology, I guess, is what I was talking about with production costs or production technology, production process. Like if you get new technology, that'll increase supply. Input prices, right? If the price of labor rises, you'll get a decrease in supply. Natural conditions, that's like the drought thing. Government policies, okay, fine. So let's see, how do these things affect supply? Well, kind of use your common sense, use your intuition, right? If there's a fall in input prices or improved technology or lower taxes, less regulations or favorable natural conditions, those will all give us an increase in supply. And the reverse gives us a decrease in supply, right? Just as I said with demand, probably the best guidance, and that you need to be able to recognize all the important shifters, right? Like you need to know the supply shifters and the demand shifters so that you can answer them, like answer questions that pertain to them. If you can recognize those on the exam, that helps you with the process of elimination if it's a multiple choice exam. But broadly speaking, or when in doubt, ask yourself, is it a change in price? If so, you can only get a change in quantity, demanded or supplied. Or is it a change in something other than price, in which case you can get a shift? Okay. Here's our 4-step process in determining how an economic event affects equilibrium. First, draw the demand and supply model before the economic change. 2, decide whether it affects demand or supply. 3, decide whether the effect causes a shift to the right or to the left. Sketch the new curve on the diagram. 4, identify the new equilibrium and compare to the original. In particular, compare the new price to the old price, the new quantity to the old quantity. This is comparative statics. They actually did a pretty good job. I like this 4-step process. This is pretty good. So you got to use your judgment to determine, does the change affect demand or supply? Here's how I like thinking about our increases and decreases in demand and supply. For increases in demand, I like thinking about that as a situation where consumers are going to get a lot more excited about whatever the product is. As a result, they'll compete with each other, driving up the price, driving up the quantity. So we get a rightward shift to demand, higher price, higher quantity. If we have a decrease in demand, we're thinking of a situation where consumers are losing interest. Nobody wants to buy it, and they buy less, so price and quantity fall. If you have an increase in supply, I like thinking about that as flooding the market. So there's just an abundance of whatever is this product, so there's a higher quantity, lower price. That's a rightward shift to supply. And if there's a leftward shift of supply, I'm thinking about that as increasing scarcity. So whatever this is really rare. As a result, people are willing to pay a lot of money for it, and the quantity available falls, leftward shift to supply. I go through that in greater depth on my Substack, on my microeconomicprinciples.substack.com. You can find my supply and demand chapter, and I talk about that. And I might have some other videos where I do that. I think actually that's helpful to build your intuition about how to interpret intuitively leftward shift of or rightward shift to demand and supply. Okay, discussion question. Using the 4-step approach, how did excellent weather conditions during the summer affect the quantity and price of salmon? Okay, so better weather, excellent weather conditions during the summer, better weather is going to cause an increase in supply, right? Increase in supply means we're flooding the market. So we're going to get a lower price and a higher quantity. Sure enough, we'll represent this with a rightward shift to supply. We'll start at S0, we'll go to S1. We leave demand where it is. So other things equal, we're not changing demand. Demand is invariant because this is affecting supply, not demand. Oh, but you might say something like, well, these better weather conditions are going to affect or whatever, buyers are going to respond. Okay, so we use what's called the one cause, one effect principle. This thing right here, this improved weather conditions, we identify this as affecting supply and supply only. Yeah, your intuition's correct. There's going to be some impact on the demand side, but the way that this reaches the demanders, the way that this reaches buyers is not a shift to demand. It's that relative to demand, we have a lower price. If price changes, we can only get a change in quantity. We get a movement along the demand curve, we get a higher quantity demanded. Right? So we have an increase in supply. This is a positive effect on supply. That's an increase in supply. A rightward shift to supply along a constant demand lowers our price. At the lower price, we have a higher quantity demanded. So on the supply side, we get a shift. One cause, one effect principle tells us we have to look on the other side for a change in quantity. That's what we got. Okay. Sometimes students will make a mistake and they'll want to, like kind of in response to this supply shift, move demand. No. Never move the other curve unless you have another shifter that's going to justify that move. That's really important. Okay, discussion question. From 2004 to 2012, the share of Americans reported obtaining their news from digital sources increased from 24% to 39%. Using a 4-step approach, how has this affected consumption of traditional sources like print media, radio, and television and news? This is a change in the number of buyers. This affects the demand side. That's a decrease in demand. Remember I said you can think of a decrease in demand as consumers losing interest? Because they literally are. So we have a lower price, a lower quantity demanded. Sure enough, we get a leftward shift of demand along a constant supply curve, right? This is affecting demand, not supply. So we get a leftward shift of demand across a constant supply curve. It's a movement along the supply curve. we get a decrease in quantity supplied. Yeah, you might realize that the legacy media here is going to figure this out. And so there's going to be some type of response, and you might be tempted to want to have some type of supply shift. You want to resist that temptation, right? Again, one cause, one effect principle. This cause is going to cause the effect of a leftward shift of demand, which lowers the price, which tells us the effect for supply. If price changes, only quantity can change, so we get a decrease in quantity supplied. Okay. Using a four-step approach, what does the increase in labor compensation as well as the increase in digital communications suggest about the continued viability of the Postal Service? Oh boy. So now we have two curves shifting. And there's a couple different ways we can do this. First, what we want to do is we want to identify what's going to be the effect on demand, what's going to be effect on supply. Sometimes we might want to put these on the same graph. If we do, you have to draw two graphs. I talk about this in my Substack where you would do, in this case, a leftward shift to supply and a leftward shift to demand, and you draw two graphs. One where supply shifted way far to the left and demand a little bit to the left, and the other where demand shifted way far to the left and supply a little bit to the left, and then track what happens to supply or to price and quantity in both cases. We can actually build that intuition just from these panels here. Increase in labor compensation. Increase in labor compensation relevant for the Postal Service means it's going to cost more to hire postal workers. So that's going to be a decrease in supply. That's an important input in rendering postal services or letter delivery or something. So we're going to have increased scarcity of postal service, right? Letters delivered or whatever. So we're going to have a leftward shift to supply. That's going to be a higher price and a lower quantity. On the demand side, there's an increase in digital communication. So this is like consumers losing interest in post office. So we get a leftward shift to demand that's going to give us a lower price and a lower quantity. Now what we want to do to get the net effect is we'll just look at these two panels. Over here, this supply effect is causing a decrease in quantity and an increase in price. Over here, the simultaneous effect in demand is causing a decrease in quantity, a decrease in price. So at the end of the day, when we add up, when we sum up kind of the effect of both of these things together, we see both stories agree on the fact that quantity is going to fall. They disagree in terms of what's happening to price. If it turns out the supply effect, these rising labor costs, has a stronger impact on the market than this turn towards digital communication, then price should rise. But if it turns out that the right panel is more descriptive, that digital communication, this loss of interest in digital communication, swamps out the effect of the increase in labor, swamps out the supply effect, then actually we should expect price to fall and quantity to fall. So if supply is the dominant effect, even though these are both happening at the same time, if supply is the bigger story, we'll get an increase in price. If demand's the bigger story, we'll get a decrease in price. In both cases, we'll get a lower quantity. Let's see, higher labor compensation causes a leftward shift to supply, decrease in equilibrium quantity, increase in equilibrium price. Change in taste away from the Postal Service causes a leftward shift to demand, decrease in equilibrium quantity, decrease in equilibrium price. They agree on the decrease in equilibrium quantity. They disagree about price. At the end of the day, knowing what actually happens or what we're actually predicting in the market requires the additional information about was it part A or was it part B that was more dominant. I hope they do more about this in this chapter. If not, you probably definitely want to refer to like my Substack chapter, and then that'll clarify that a little bit better. Okay, superimposing the two previous diagrams on top of each other, we'll see the supply and demand shifts cause changes in the equilibrium price and quantity. Oh boy, I do not like drawing this just on one graph like this. And the reason why is if you only draw one graph, this misses the point, misses the fact that you could have different magnitudes effect of this demand and supply. Also, there's a way you can draw this. If we were to draw this a little bit different, that would make the quantity, that would make the, it'd make the price not change at all. Right? Like if we drew this supply curve, S1, a little bit further to the right, it would cross this demand curve at exactly this point, and then it would look like the price stayed the same. And then students get the question wrong because they say at the end of the day, quantity decreases, but price stays the same. And that's wrong because it's only one of three possibilities. Okay, so I think this is actually bad advice. I think if you want to draw I mentioned you can draw the two diagrams together, you should actually draw two pictures. The better thing to do is to draw two graphs that look like this. One where you have a very small leftward shift of supply, but a big shift in demand, and the other picture where you have a small shift in demand and a large shift in supply. If you've never done that before or never seen it or don't want to bother finding my Substack to see it, draw it for yourself real quick. Stop the video and just draw like those two graphs, and you'll see the before and after impact on demand and or the price and quantity. The other thing that I really don't like doing about this is that this is really hard to track, like what was the before and after. Just you have to look at the labels. When I draw my changes, my comparative statics graphs like this, I like drawing demand D naught and S naught, my initial demand and initial supply with bold, with a solid line. And I like drawing my shift with a dashed line. And then I use dots if I need to label the price and quantity. The reason why is you can always, if you look at my graphs in my Substack, you'll see the bold X will be the starting point, the dashed one will be the change, and that's real easy to use that convention and then track what's happened. Oh wow, yeah, they actually don't even give that. No, yeah, okay. So hopefully what I said adds a lot of value here, because I could see how these slides could be super confusing. All right, so movements are different than shifts. So shifts are like you move the entire supply relationship or the entire demand relationship. In particular, you're getting a new quantity demanded or new quantity supplied at every single price. A shift in one curve never causes a shift in the other curve. Rather, a shift in one curve causes a movement along the second curve. Yep, this is basically my one cause, one effect principle. One side gets the shift, the other gets a movement along the curve, which gives us a change in quantity. Oh, and that's all they say about it. Okay. Next, price ceilings and price floors. Price controls. So these are laws governments enact to regulate prices. Price ceiling keeps a price from rising above a certain level. It's a legal max that one pays for some good or service. It's going to prevent, it doesn't specify what the price is going to be. It says where the price can't go. It can't go higher than where the price ceiling is, right? Price floor keeps the price from falling below a given level. It's the lowest price you can legally pay for a good or service. Again, it doesn't say what the price has to be. It says it can't go below it. Now, if the price ceiling is below the equilibrium, it'll be binding, and then the price ceiling becomes the price. It'll also cause a shortage, because if we're below the equilibrium, we know from earlier in the lecture here, you'll get a shortage anytime you have a below equilibrium price. A price floor prevents the price from going lower, so if we place the price floor above the equilibrium, then it'll cause a surplus because you have an above equilibrium price. Okay, so here's an example, rent control. Here's our initial demand, D naught. Here's our initial supply, S naught. And then we've got our price ceiling set at 500. The equilibrium, let's see, the equilibrium, okay, so the equilibrium is at 500. We originally set the price ceiling here at 500. No problem, no shortage, because we set the rent control at exactly the current prevailing level of rent. Then we get an increase in demand. Now there's a problem, because if supply stays the same, now at the price, now the new equilibrium is 600, but the price ceiling's not allowing the price to rise in that market to the equilibrium, which means at the price of 500, our quantity supplied is 15,000, but at the price of 500, our quantity demanded is 19,000. So we have a shortage of, 4,000 units, right? So that's a problem. The original intersection of demand and supply occurs at E naught. If demand shifts from D naught to D1, the new equilibrium would be at E1 unless a price ceiling prevents the price from rising, such as it does here. If the price is not permitted to rise, the quantity remains at 15,000. However, after the change in demand, the quantity demanded rises to 19,000, resulting in a shortage of 4,000. This would be a binding price ceiling, right? Okay. So price floor example, European wheat prices. So price floor, this is a price floor above the equilibrium. This is a binding price floor. It's not allowing the price to go below this. So here's our quantity demanded. Here's our quantity supplied. So we have a surplus. The intersection of demand and supply would be at equilibrium point E naught. However, the price floor set at PF holds the price above E naught and prevents it from falling. The result of the price floor is that quantity supplied, right here, exceeds quantity demanded. Surprise, surprise, this is an above equilibrium price, so of course there's a surplus. gives us excess supply, also called the surplus. Yep. Okay. Now, demand, supply, and efficiency. Consumer surplus, that's the amount individuals would be willing to pay minus the amount they're actually paid. That they actually paid. It's the area above the market price and below the demand curve. That's right. Producer surplus is the price the producer actually received minus the price the producer would have been willing to accept. So it's basically price minus marginal cost. It's the area between the market price and the segment of the supply curve below the equilibrium. That's right. Graphically, consumer surplus is the area under demand above price. Producer surplus graphically is the area under price above supply or above marginal cost if you have like a monopoly. Okay, social surplus, economic surplus, total surplus is just the sum of consumer surplus and producer surplus. Deadweight loss would be a measure of inefficiency. This would be the loss of social surplus occurring when a market produces an inefficient quantity. Deadweight loss refers to the inefficiency that enters when there are value-creating transactions that don't happen. And we could see that immediately if we have the wrong price, if there's a shortage or surplus. That's probably the example they've got. Okay, here's consumer and producer surplus. So the equilibrium price is going to be 80. The equilibrium quantity is 28. Consumer surplus is the area under demand. It's this triangle. And the area under demand and above the price. And the area under price and above supply is producer surplus. And these together, consumer and producer surplus, gives us total surplus, or they're calling this social surplus. We've labeled consumer surplus with F. We've labeled producer surplus with G. Okay. So notice these are labeling areas. J, E, and K are all points. Okay. So suppose we have a price floor or price ceiling. Here's a price ceiling. The price ceiling tells us while the equilibrium price is 600 and equilibrium quantity is 20,000, the price ceiling is not allowing the price to rise above 400. So the quantity actually supplied is 15,000. Now, I like introducing a concept called the quantity traded or the quantity transacted. That tells us how much it actually changes hands. That's always the smaller of quantity demanded or quantity supplied in price floor or price ceiling examples. In a price ceiling example, this is below the equilibrium. Quantity supplied, this is the supply curve. Quantity supplied at the price of 400 is going to be smaller than quantity demanded. They didn't label it, but it's way out here. The quantity actually traded is going to be 15,000. That's a problem because that means we lost 5,000 units that would have been traded, corresponding to area U and area W. All right, so the original equilibrium was 600 with a quantity of 20,000. Consumer surplus is T plus U at that price. Producer surplus would have been V plus W plus X at that price. The price ceiling is imposed at 400, so firms in the market now produce a quantity of only 15,000. As a result, new consumer surplus is just TV. So those consumers who are able to consume those 15,000 units are better off. The producer's worse off. They lose area V, they keep only area X. But then the market as a whole lose area UV. That's UW. That's deadweight loss. All right, in this example, we have an equilibrium at $8. We have an equilibrium quantity at 1,800. We imposed a price floor at $12. That's not allowing the price to go lower. The price wants to be at 8. It's not going to get there. It's going to stay at 12. At the price of 12, the quantity demanded is 1,400. The quantity supplied is way out here. The quantity actually traded is 1,400. That's the amount that's actually in the market, which means we lost 400 units and the ability to generate value from trading those 400 units. So J and K are deadweight loss. Previously, G, H, and J were consumer surplus at this equilibrium price. Previously, I and K were producer surplus at that equilibrium price. At the price floor, consumer surplus is G, consumers lost area H, and area J, and producers gain area H. So producer surplus rises, it's going to be HI. Consumers lose area J also, that becomes deadweight loss from consumers. Producers lose area K, that becomes deadweight loss from producers. And the idea is that this is going to capture the inefficiency in this market. Deadweight loss, more formally, or like graphically, is going to be the lost inefficiency from the efficiency that enters from the loss of transactions of those units. You can always find it graphically because it's going to be the area between demand and supply over the units no longer produced, right? As a result, in this case, of the price control. Okay, that brings us to the end here. So let's see. We'll go ahead and conclude. I hope you enjoyed this lecture, and I will see you in the next one. Bye.